Welcome back. Today, we are going to crack the code of how computer networks are defined. But here's the thing. We're not going to do a single bit of math. Not yet. First, we need to understand the structure. Because once you get the structure, all the math that comes later, it becomes so much easier. All right, let's get into it. So let's start with a little mystery. You've seen an IP address like this a million times. 192.168.1.25. But what is it actually telling you? Well, on its own, not much actually. It's kind of like having a house number, but you don't know the street, the city, or the zip code. It's a puzzle with some really important pieces missing. I mean, without any other context, this string of numbers doesn't tell us a whole lot. We have no idea how big this network is. Is it for a handful of devices or thousands? We don't know where the network's boundaries are. We can't even tell which devices are its next-door neighbors and which ones are way out on the other side of the internet. It's just an address floating in space. So, how do we fix this? How do we solve the puzzle? Well, we introduce the crucial missing piece, the subnet mask. The best way to think about it is as a boundary marker. It draws the property lines for our digital address. Its job is actually super simple, but incredibly powerful. A subnet mask takes any IP address and just draws a line right through it. It splits it into two separate parts. On one side of that line, you have the network portion, and on the other side, you have the host portion. Let's stick with our address analogy. The network portion, that's the street name. Everyone who lives on Main Street shares that part of their address, right? The host portion, that's the unique house number, 123 Main Street. The network part is what everybody in the neighborhood has in common, but the host part is what makes each device unique. That's really the core idea here. And here's why that matters in the real world. Every single time your computer sends a piece of data, it uses the subnet mask to ask one critical question. Is the place I'm sending this to on my local street? If the answer is yes, great, it can talk to it directly. But if the answer is no, it knows it has to hand that data off to a router to figure out how to get it to that remote destination. This is the fundamental rule that separates local talk from internet talk. Okay, so writing out a full subnet mask, 255.255.255.0, that's kind of the old school way of doing things. These days, we have a much cleaner, much more powerful shorthand for drawing that same boundary line. And it looks like this. You've definitely seen this before. It's just a simple slash followed by a number. This is often called CIDR notation, but most people just call it slash notation. And this little thing tells us everything we need to know. So what's that number actually mean? It's just a count. It's that simple. A /24 just means that the first 24 bits of the IP address belong to the network portion. That's it. It's just a super efficient way of telling everyone, hey, this is where the boundary line is. Now, this is probably the most important concept to get your head around, and it can feel a little backwards at first. The bigger the prefix number, like a /26, the smaller the network is. Why? Because you're using more bits to define the network, which leaves fewer bits for your devices. The opposite is also true. A smaller prefix number, like a /16, means you get a much larger network that can hold way more devices. Okay, this is where the light bulb really goes on. Let's actually visualize how changing that little prefix number literally reshapes the entire network just by moving that boundary line we've been talking about. All right, so here's our starting point, a classic /24 network. The first 24 bits are for the network, and that leaves the last 8 bits for all of our devices, our hosts. That gives us a pretty decent amount of space. Now, watch what happens when we change it to a /26. See that? The boundary line just shifted to the right. We basically borrowed a couple of bits from the host side and given them to the network side. And look, the space for host just got smaller. That means this is now a smaller network with fewer devices. But what if we go the other way, to a smaller prefix, like 16? Whoa, the boundary shifts way over to the left. We've given a whole bunch of bits back to the host side, making it absolutely massive. This creates a much larger network that can handle thousands upon thousands of devices. So let's be absolutely clear about what just happened. We didn't change a single IP address in any of those examples. All we did was change the rules about how they're grouped. We just slid that boundary line around, and by doing that, the exact same range of addresses can either be one giant network or it can be chopped up into a bunch of smaller, separate networks. So why do we care about any of this? What's the big payoff? Well, it's because this boundary is everything to the devices that make the internet work. Routers. Routers live and breathe by these network definitions.
A router's job sounds complicated, but it's really pretty straightforward. When a piece of data shows up, the first thing it does is look at the destination IP address. Then it uses the prefix, the subnet mask, to figure out just the network part of that address. It completely ignores the individual device part. Then it just looks at its map, its routing table, and goes, oh, okay, that network is over there, and it forwards the packet on its way.
And this is a huge point to remember. Routers are like the main postal sorting facility for a country. They don't care about your specific house number or your street. They just need to know which city to send the mail to. Once the letter gets to the right city, the right network, somebody else, like a local mail carrier, can handle the final delivery. Routers think in terms of networks, not individual hosts. Now, it's also really important to understand what subnet masks don't do. They only draw the boundaries. They do not assign IP addresses. That's the job of something called a DHCP server. They don't route traffic themselves. That's what a router does. And they definitely don't provide any security on their own. All a subnet mask does is draw the map that all these other systems use to do their jobs correctly. And that brings us right back to where we started. The whole philosophy here is structure first, math second. If you really understand what a subnet mask does, what that prefix number means, and how moving that boundary changes the shape of a network, well then any math you have to do later just becomes a simple exercise. You get the why before you have to worry about the how. So there you have it. We've laid the entire foundation. You now get the structure of network boundaries, how they're defined, and most importantly, why they matter so much. Which brings us to the big question. Now that you understand the structure, are you ready to see just how easy the math can be? We'll find out next time. Thanks for joining me.